हेलो फ्रेंड्स, वेलकम टू आवर चैनल आज जिंदगी एडू केयर। Our channel provides learning materials for maths and science from class 8 to class 12. Please visit our playlist section to get the benefit of these online materials. Okay friends, so today we are going to discuss sets. In sets we will discuss what is a set. Then we will discuss roster form and set builder form of a set. Then we will see different types of sets. Okay, friends. Then we will see also some problems related to sets. So, what is a set? If we say what is a set, see a well-defined collection of objects. So we can say set is a well-defined collection of objects. Objects or items, whatever you can say, objects or items. Okay, so if we say, can we give some example of a say? If I say the collection of vowels in English alphabet, so what will be our set? See, if I say collection of vowels, collection of vowels, so this is a set because it is a well defined. Then if I say collection of first five prime natural numbers, this is also a set. Collection of first five natural prime natural numbers. Okay, prime natural numbers. Okay, then if I say collection of good cricket players of India is not a set because good player is vague and it is not well defined. So we can say collection of good players of Indian team is not a set. Okay, because it is not clear and it is vague, not clearly defined, not clearly defined. Okay, because someone may say about a player that he is a good player, and in other person's view he may not be a good player, so it is not a set. So if some items, what are the items of the set that we called elements of the set? Okay, so we denote sets by capital letters like A, X, Y. Okay, these are okay. So elements, how we identify? Elements are identified in small letters A, B, C, D. These are elements of sets. Element of sets. Okay. So if I say that a small a is an element of X, okay, this is a symbol of element. So a is an this is read as this we can read as a is an element of set X. Okay. So next we will see. Just let me clean this. If I denote natural numbers, so I can write n as set of natural numbers. Set of natural numbers. Similarly, I can write set of rational numbers as q, set of rational numbers. Z we can write as set of integers. Okay. Then if I write R is set of real numbers, set of real numbers. Then C we can define as set of complex numbers, all complex numbers. Okay. So next we will see description of a set in two forms. So one form is roster form or tabular form we say. Second form is set builder form. So let's in this we will start with description of a set. Description of a set. First one is roster form or tabular form. Roster. Second one is set builder form. Set builder form. Now we will see what is a roster form and set builder form. So we will discuss with roster form. This is roster, roster form and set builder form. Okay. So roster form. So what is a roster form? In this form, a set is described by listing elements separated by commas within braces. Okay. So in this set is described by described listing elements separated by commas within braces. Okay. So this is your roster form. As an example, if we say set of vowels of English alphabet, so this can be denoted as set of vowels. Okay. If we write set of vowels, what will be our set? A, E, I, O, and U. So these are, see, it is listed by writing each element and separated by comma, and all our elements are written within braces. So next example, if we write set of even natural numbers. So how we can write set of even natural numbers? So this we can write as even natural numbers means 2, 4, 6, 8, and so on. See, this dots stands for and so on. Okay, dots stand for and so on, because we cannot write all the elements of even natural numbers. Okay, then set of all prime numbers less than 11. How we can write that? Set of all prime numbers less than 11. So what will be all the numbers? It will be, see, if we write a is equal to set, so a equal to 2, 3, 5, and 7. 11 will not be included here as it is writing less than 11. So these are the elements of this set A, which contains all the prime numbers less than 11. Okay, see, if in a set we write all the elements in different order, it makes no difference. Okay, if we write a equal to 2, 3, 5, 7. Okay, this is same as if we write 2, 7, 5, 3. Order does not make any difference. You can note it down. First, order in which the elements are written makes no difference. Okay, so all this A, even if we write say 7, 5, 2, 3. Okay, all are same, and even repetition of an element has no effect. So second point you can note down, repetition of an element has no effect. If for example we consider A equal to 1, 2, 3, and another set we consider, this will be same for if we write 1, 2, 3, and 2 is repeated. So these two are same, even 2 is repeated twice here. Okay friends. So this is all about roster form. Next we will discuss set builder form. So first we will clean this. Second is set builder form. So what is a set builder form? In this form, a set is described by characterizing property of its elements. So In this form, we can write in this form a set is described by a characterizing property if our element is x, so property can be denoted as px of its element x. So set is defined by its property, characterizing property. Okay. So in such a case, set is described by. So in this, how we write if A is a set, so we write A equal to x, we write colon. That means x such that, colon means such that px, property of x, holds. Okay. So whatever be its property, we write x such that px holds or px is true, or even this is indicated as x such that we make a straight line, x such that px holds. Okay, so this column or this line I will write, or that will make a good sense. Column or straight line this read as such that. Okay, such that. So we read this as the set of all x such that px holds whatever be its property. Now, if we consider an example, set E of all even natural numbers. So E is a set of, this is an example. E is set of all even natural numbers. So natural numbers is a property and even also even natural numbers. Okay. So how we write this set? We will write E equal to x such that x is a natural number and x equal to 2n for n is an element of natural number. So x equal to 2n such that n is an element of natural number. We can write like this, or even we can write as E equal to x such that x is an element of n, x equal to 2n, and n is an element of n. Okay, if we write 2n, then it will be even only. Okay, friends. Or we can also write as E equal to x is an element of n such that x equal to 2n and n is an element of n. So in this way we can write in different forms. So if we want to convert or we want to write a roster form into a set builder form, so one example is write it. If A equal to, in roster form it is given as 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this is in roster form. If we write this in set builder form, we can write as A equal to x is an element of natural number such that x is less than or equal to 9. Okay. If we have another example, we will consider set A is given as 0, 1, 4, 9, 16, and so on. Dot 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 stands for and so on. So in this is in roster form, and this is your set builder form. So now 0, 1, 4, 9, 16 in set builder form we can write as A equal to x square such that x x square such that x is an element of, see this, either it can be minus 2 or plus 2. Minus 2 square is also 4, and minus 3 square is also 9, even plus 3 square is 9. So x will be an integer. So we can write x is an element of z. Okay friends. So we have discussed set builder form. Next we will discuss a problem. Write down the problem. Describe the set in roster form. Okay. So describe the set in roster form. So first one is in the set of all letters in the word mathematics. First one is the set of all letters in mathematics. So if we write this in the form of a set, we can write A equal to, if A is the set, then see what are the letters repeated that we will not write again. So M will be MAT, see this MAT is repeated. So only distinct letters we will write here. So MAT, then HE, then again MAT is repeated. We will leave that, and ICS. So mathematics. Order does not make any difference here. So we can write all the letters in any order. Okay, friends. Second, if we take write the word algebra. So we have to consider this word algebra. So if X is a set, we can write in roster form as C A L G E B R, and A is repeated, so we will leave that, as it does not make any sense to write again and again same letters. Okay. So this is written in roster form. Next we will take problems on set builder form. So describe the following sets in set builder form. Set builder form. Okay. First problem is set of reciprocals of natural numbers. Set of reciprocals of natural numbers. So how we can write that? So see, we can write this as if A is the set, then A we can write as A equal to X such that X is a reciprocal of a natural number. In the property form, we have written this number. Or also A can be written as X such that X equal to 1 by n and n is an element of natural numbers. Okay. So in this way we can write. Next problem, second problem we will see. The set of all odd natural numbers. Set of all odd natural numbers. So if x, or we will take b. If b is the set of all odd natural numbers, this can be written as x such that x equal to, see, odd natural number. So 2n is even. So for odd we can write 2n minus 1, where n is an element of natural number. Okay, 2n minus 1 will be odd. So in this way we can write in set builder form. Okay friends. So we will clean this. Next we will write another problem. Write the set. Write this question. Write the set. It is given in roster form. The set is 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7, 7 by 8, 8 by 9, and 9 by 10. So these are 9 elements of this set, and we have to write this set in set builder form. Okay friends. So if we see this, consider any element 1 by 2. So first element, if we observe the first element, the number begins with 1 and denominator is 2. Okay. Second element you see 2 and denominator is 3. So we can write in set builder form. See, we can observe denominator is 1 more than the numerator in all the elements. Okay. So we can write this set A as A equal to X such that X equal to 1 by, sorry, 1 no, n by, okay, n, I will write it clearly, n by n plus 1 because the denominator is 1 more than numerator, and n is an element of natural number. Also, n is less than equal to 9. So in this way we can write a roster form in state builder form. Okay friends. Then if we have to write a state builder form in roster form, how we can write? We will take another problem. So consider a problem. We have to write state builder form in roster form. Okay. So set is given in the roster form as a equal to an such that n is an element of natural number an plus 2 equal to an plus 1 plus an a1 equal to a2 equal to 1. Okay, so a1 and a2 are given as, so if we see how we can proceed here, see a1 is given as 1, a2 is given as 1. So an plus 2 equal to an plus 1 plus an. So a3 we can calculate from the given formula. A3 will be a1 plus 1. So a2 plus a1. So it will be 1 plus 1 equal to 2. Similarly, if we write a4, a4 can be written as a3 plus a2. So a3 is 2 plus 1 equal to 3. A5 equal to a4 plus a3. So 3 plus 2 equal to 5. And we can write a6 equal to a5 plus a4. And a5 we have 5 plus a4 is 3. So this is 8. And so on we can write. So set A in roster form can be written as A1, A2, A3, A4, then A5, A6, and so on, which will be equal to 1, 1, third element is 2, fourth element is 3, then fifth element is 5, sixth element is 8, and so on. So in this way, we can write roster form in set builder form and set builder form in roster form. Okay friends. Next we will discuss type of sets. So let's clean this. Types of sets. Okay. First one is empty set. Empty set. So what is an empty set? See, a set is said to be empty or null or void set if it has no element and it is denoted by high. Okay, so it is said to be empty if a set has no elements, no elements. Okay, then set is said to be empty set or null set or void set. Okay, it is denoted by phi. Okay, so in roster form, phi is denoted as like this. There will be no element. Okay, friends, and an empty set is, so in the roster form, if we want to write, see, from the definition we conclude that a set is an empty set if the statement x is an element of A is not true for any x. So please note this: a set is an empty set if the statement x is an element of set A is not true for any x. Okay. So if we consider an example, say a set A such that A is a set, so x is an element of real number such that x square equal to minus 2, and we know that square of any real number cannot be negative, so it will be a void set. Okay. Similarly, if we take another example, set A is given as x is an element of natural number such that x is greater than 2 and less than 3. So, a natural number cannot be a fraction and there is no integer in between 2 and 3. So, it will also be a void set. Okay, friends. So, if A and B are two empty sets, then x is an element of A is satisfied because there is no element x in either A or B. Thus, we can take A equal to B. So, there is only one empty set and we denote it by phi. Okay. Next type is, so first we will clean this. Second type, singleton set. So a set consisting of single element is called a singleton set. Singleton set. A set consisting of single element. What will be example? See, if we write set A is equal to 5, so this is a singleton set, and another example we may write b equal to x such that x is an element of n and x square equal to 4. So x square equal to 4 and x is a natural number. It will give only one element which will be equal to. So this is a singleton set. Singleton set equal to Only one element will be there, 2. Okay. Cardinal number of a finite set. So first we will see what is a finite set. Next, third number, finite set. Okay. So what is a finite set? A set is called finite set if it is either void set or its elements can be listed or counted by natural numbers 1, 2, 3, and process of listing terminates at a certain natural number. So a set is called a finite set if it is either void set or its elements can be listed or we can write counted, listed or counted by natural numbers. Okay, natural numbers such as 1, 2, 3, and so on, and process of listing terminates at a certain natural number, say n. Okay, certain natural number n. So cardinal number of a finite set. So for what is a cardinal number of a finite set? The number n in the above definition of finite set is called the cardinal number. So the number n as considered in finite set definition is called cardinal number and is denoted as n of set A. Okay, friends. So finite set we have discussed. Next is infinite set. Fourth is infinite set. So a set whose elements cannot be listed by natural numbers for any natural number n is called an infinite set. A set whose elements cannot be listed by natural numbers such as 1, 2, 3, and so on for any natural number n. Okay, so its elements cannot be listed by any natural number n. So we will consider example of finite and infinite set. Let me clear this. So if we write example, okay, finite set first we will consider set of even natural numbers less than 100. Okay, set of even natural numbers less than 100. So even natural numbers less than 100 can be listed. Okay, friends. Next is set of even prime natural numbers. So even prime natural numbers is only two. Set of even prime natural numbers. That is also listed, cannot be listed. Natural numbers. And it is equal to 2 only. So since it can be listed, so it is finite set. Next we will consider example of infinite set. So what are example of infinite set? If I write set of all points in a plane, so it cannot be counted or it cannot be listed. Set of all lines in a plane, this can also be not listed. Or set or in set builder form, x is an element of R and x is less than 1 greater than 0, as there are infinite real numbers between 0 and 1. So this is also an infinite set. Next is we will clean this and next we will consider fifth type, equivalent sets. Equivalent sets. So what are equivalent sets? Two finite sets A and B are equivalent if their cardinal numbers are same. Two sets are equivalent if their cardinal numbers, sorry, we will write two finite sets, that will be more clear. Two finite sets are equivalent if their cardinal numbers are equal. So if two sets we have A and B, so if NA equal to NB, then these two sets are equivalent sets. Next type is equal sets. So what are equal sets? Two sets A and B are said to be equal if every element of A is a member of B and every element of B is a member of A. So two sets A and B are equal if every element is of A is a member of B and every element of B is a member of A. Okay, friends. So this is example of equal sets. This is definition of equal sets. Now we will consider example of equal sets. So if A equal to suppose 1, 2, 5, 6 and B is equal to 5, 2, 6, 1. So we can notice that element 1 is in A also and B also. 2 is in A also, B also. 5 is in A also and B also. So all the elements of A is in B, and even we can say all the elements of B are in A, and none of the elements in A is not in B. Okay, friends? So we can write A is equal to B. These two are equal. A equal to B, equal sets. Okay. Next, we will consider example of equivalent sets. So, if set A is equal to 1, 2, 3, and set B is equal to A, B, C. So, if we see number of elements in A or cardinal number of A equal to 3 and cardinal number of B, that is number of elements in set B, is also 3. So we can say A and B are equivalent sets. Okay, friends. So today we have discussed definition of a set. Then we have seen roster form and set builder form. After that, we have seen types of sets, in which we have discussed empty sets, singleton sets, finite sets, infinite sets, equivalent sets, and equal sets. Okay, friends. I hope every one of you have understood the lecture. If you have any doubts or query related to this lecture, please let me know in the comment box. Also, if you like the video, please like it and subscribe our channel Aha Jindagi Edu-Care. Also press the bell icon button so that you will get notification when next video will be uploaded. Okay, friends, thank you.